All right, we're going to be doing lesson 3-3, multiply 3-digit numbers by 2-digit numbers. And I can multiply a 3-digit by a 2-digit number. And in order to do this, we're going to use some simple computation and some standard algorithms. And we're going to be actually looking for the partial products. So this is building on prior knowledge that you have already in math. So if we have 163 times 14, that is going to be the problem we're trying to solve. 163 times 14, written in the traditional algorithm, is like that. But what we're saying is you can actually go back to your fourth grade brain and say, can I do 163 times 10? Why am I using 10? Because 14 has one 10. So I can do that pretty quickly. I take my digits and I annex 0. And can I do 163 times 4? Which is 163 times 4. Sure, your fourth grade brains can do that. 4 times 3 is 12. Put the 2 down and carry the 1. 4 times 6 is 24 plus 1 is 25. 4 times 1 is 4 plus 2 is 6. So watch what happens over here when I use the traditional algorithm. I'm going to use the distributive property starting in the ones place in my secondary factor here. 4 times 3 is 12. Put the 2 down, carry the 1. 4 times 6 is 24 plus 1 is 25. And 4 times 1 is 4 plus 2 is 6. And now I'm going to use the distributive property for the 1, which is actually a 10. 1 or 10 times 3 is 30. And then I'm going to say 1 times 6 is 6, and 1 times 1 is 1. So when I add these together, I get 2,282. Now let's take a look over here, because if I add this partial product, which is 163 times 10, and this partial product, which is 163 times 4, am I going to get the same answer? And if you look on the other side, you can see the digits are the same, so I am going to get the same answer. So you can use partial products and use the distributive property to help you solve larger numbers. Build on what you already know how to use from your lower grades, the single digit multiplication and the base 10 multiplication. So let's move along. And you know, in this chapter, we're going to throw some decimals in, but not quite yet. So as we go down to the bottom, how can you check to see if your answer is reasonable? Well, we can always use estimation. We had 163 times 14, and we said it was 2,282. So if we wanted to see if that answer was reasonable, we could estimate the values. We can bring that all the way up to 200, maybe times 15, which would get me 3,000, and that looks reasonable there. Or maybe you would do 200 times 10 would get you 2,000, and that's reasonable as well. So using estimation is really important in the multiplication chapter. Really important to estimate, because for a lot of you, going back and trying to remember how to multiply, you might need that extra reinforcement of using estimation. Okay, how do you multiply a 3-digit number by a 2-digit number? You can use multiplication to join equal groups. So here we have, last month the bakery sold 389 boxes of bagels. How many bagels did the store sell last month? So let's see, how many bagels did the store sell last month? Multiply the ones and regroup if necessary. Multiply the tens and regroup if necessary. Add the partial products. And there's 12 bagels per box. So we have 389 times 12 is the same as saying 389 times 10 plus 389 times 2. So what we're doing here is 389 times 12 is the same as 389 times 10. I don't even have to write that out, but 389 times 10, remember, we just write the digits and annex a 0 for the base 10. And 389 times 2, which in this case, you could even add 389 twice. If you're feeling wiggly with your multiplication, you could just add it twice. Whatever you need to do. So when we combine these two, we should get our answer. So let's take a look. 389 times 12. 9 times 2 is 18. We carry the 1. 2 times 8 is 16, plus 1 is 17. Carry the 1. 2 times 3 is 6, plus 1 is 7. 10 times 9 is 90. 1 times 8 is 8. And 1 times 3 is 3. And remember, it's not really a 1, it's a 10. And I know I'm saying 10 times 3 is 3,000. And I know that's right because in place value, that is in the 3,000s. So now let's see what I have down here. 3890 plus 778. 3890 plus 778. Yep. So don't get scared by double digit and triple digit multiplication. You're just going to break it apart. That's what everyone does. We use the distributive. We're going to move by the end of the topic. You'll be able to use the distributive property and do double digit multiplication very, very easily. Now, of course, if you don't know your math facts, this gets pretty tricky. So I suggest if you don't know your math facts very immediately, you can have a math table, a math facts table next to you to help you out. You could use a calculator to help you on your math facts if you needed it, but you're still going to have to learn how to do this by yourself without a calculator. So if you want to use it to help you out because you're not strong with your math facts, you can do that. But make sure you remember that you're going to have to get to the point where you don't use a calculator on this. A theater can seat 540 people at one time. How many tickets are sold if the theater sells out every seat for one 30-day month? So 540 times 30 days. Now, don't get scared because you can do 540 times 3. We did that in 4th grade. 540 times 3 is, and then we're just going to annex a 0. So, or you can just use the distributive property here. So I know that 540 times 10 is 5,400. And I know 30 equals 10 3 times. This is another way you can do it. So this is 540 times 10. For those of you that don't, and we just did it 3 times because times 10 times 10 times 10 would be like saying times 30. For those of you that are still really not comfortable with your times tables, but you feel really strong in addition, you can always use that strategy. So our answer is 16,200. If you do use the traditional algorithm, 540 times 30, 0 times 540 is 0. 30 times 0 is 0. 3 times 4 is 12. 3 times 5 is 15 plus 1 is 16. So that's using our traditional algorithm. Is 500 times 30 a good estimate for the number of tickets sold? I would say it's a good estimate. And if you look at it, if you look at the actual problem, they're saying if you rounded that down to 500 and you left the 30 alone and you use the simpler problem, 5 times 3 is 15, bring your 3 zeros over. So I would get 15,000. Is that a reasonable estimate? Sure it is. It's an underestimate because I rounded this value down. This one stayed the same. It makes it an underestimate, but it is reasonable. So now you're going to notice that in your math, there's not a lot of problems. You really need to have a notebook to do this. There's just not enough space in your textbook to do these. And you can check your work on a calculator. I would advise that. You can use your estimation strategies to figure out what your answer should be around to see what's reasonable. So for number 3, in my notebook, this is what I would do. In my notebook, I would write the problem, put the page number, number 3, 236 times 46 is my problem. Right next to it, I would do my estimate. So I think I'm going to say largest place value, I would round 236 to 200, and I'm going to round 46 to 50. So when I multiply that out, solve a simpler problem, 2 times 5 is 10, annex my 3 zeros, my answer should be around 10,000. So now when I go to actually solve my problem, don't get scared by this, because remember, don't get nervous because there's big numbers here. Remember what you're doing. You're going to be doing 236 times 6 first. So you're just doing it all in the same problem, but you did this in 4th grade, so don't be frightened. 6 times 6 is 36. Carry the 3. We're kind of ignoring that 4 right now. 6 times 3 is 18, plus 3 is 21. And 6 times 2 is 12, plus 2 is 14. And now we're going to use 236 times 40, which is the second partial product. So 4 times 6 is a 40 times 6. 4 times 6 is 240. So I'm going to leave the 40 here, carry the 200, carry the 2. 4 times 3 is 12, plus 2 is 14. Carry the 1. 4 times 2 is 8, plus 1 is 9. Add that together. So when I look at my estimate, I said 10,000. My actual answer was 10,856, and that is reasonable. My estimate was reasonable. My answer looks good. And remember, you want to show all your work in a notebook. We're not just running on a calculator to do this, because that's not going to help you when you take a test or anything. 61 times 25 is the same as saying 61 times 5 plus 61 times 20. And you did those kind of problems last year. So 5 times 6 is 5. 5 times 1 is 5. 5 times 6 is 30. 20 times 1, 2 times 1 is 2. But remember, I'm moving that over, annexing a 0 there, because it's really 20 times 1. And 20 times 60, or 2 times 6, is 1,200, or I can put it 12, because when I do 6 times 2 is 12, it's putting it right in the right place value. So 1,525. And to see if that was reasonable, 60 times, well, we'll round that up to 30, is 1800. Yeah, that looks reasonable to me. And so on. So there you go. I'm not going to continue on. I think I kept you long enough today. You kind of get the idea. Make sure you watch the video from Savvas if you feel like you need a little reinforcement, or you can go back over my video and check the playlist. I put some videos up by other professional math people that might help you. Have a good day.